Hello everyone and welcome to session 4 of our computer class with class 6. Our class so far has been on chapter number 1 of your computer book. Today we are going to be continuing from where we left last time. So I shall not bother you for too long. Without further too much talk, let us begin with our class today. In the previous class, we had studied till page number 6 of your computer book, where we had talked about the two types of languages, that is the low level language and the high level language. We had also talked about the various differences, the advantages, the disadvantages of the various languages. Once again, I will tell you, for those people who have not attended the previous class, you can go back to the main classroom and check out the class of the last session. Okay, today we are going to begin with page number 6, latest high level language. I will give you some time to start, open up your book and come to latest high level language. I'll count to 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, so before I begin with the class, the concept of the class is very simple. I'm going to be explaining you this for this particular part of the computer chapter. You will note down whatever confusions you may have. Just give me a moment. Alright, you will note down whatever confusions you may have on a rough notebook, and you shall comment in the comment section of this particular post in the GCR. Okay, and you can post the comments and I shall reply to them. Sorry for that. I shall reply to you as and when I find the time. Okay, now so let us begin with latest high level languages. We have discussed low level languages and high level languages. So the latest high level languages were made of WHAT, of the problem which is coded, that is, only what is required is to be specified and rest gets done on its own. Thus these languages were made to cut down on development and maintenance time, making it easier for programmers. Such languages have been designed with a specific purpose in mind, and this might include languages to query databases, to query databases, SQL, languages to make reports, crystal reports, and languages to construct user interface, XUL. Thus the programmers only need to worry about what the problem needs to be solved and what conditions need to be met, without worrying much about the implementation details to solve them. Moreover, these languages contain enough tools and components to design graphic interface that require simple efforts like drag and drop, and therefore the programmers need not waste their time in designing the interface and can concentrate only on the tasks to be performed for each of the component. Now the latest high level languages are basically languages that are specific for a particular kind of job. Alright, when you want to program a computer, what do you want to exactly do? Do you want to make a database? Do you want to make a crystal report? Sorry for that again. And also, if you want to have an interface is basically how the computer looks in front. Okay, the computer behind the back is basically low level languages. Behind the back in the sense that the computer actually is low level languages, the machine language, but you and I cannot understand that language. So The computer basically, with the help of this language, shows us a very easy format and we work upon it. Okay, whether it's your desktop, whether whatever you see on the screen right now also, these are all basically called interface, graphic user interface, in which it is very easy for us to take a mouse, scroll, click here and there. Okay, remember, in machine languages these are not there. In machine languages there are only numbers and digits. Alright, 0 and 1, you have to make combination. But the graphical user interface allows you to take your mouse cursor from one place to another, go close, go far, whatever you would want them to be. Okay, so latest high level languages basically are designed or used for designing the particular task. What kind of language, what do you have, accordingly you will choose the kind of language that you would want. All right, now for example, such languages are Visual Basic, Visual C++, Structured Query Language, SQL. These are simple examples. Okay, these are names of various languages. Okay, Prolog, OP, 55, Mercury, etc. Okay, now you see these are small. There are three logos given here. These are the three logos. This is of Visual Studio. The next one is that of MySQL, and the other one is that of SQ Prolog. All right. Language processors. Now, language processors. By now, you must be knowing that computer understands only one language, that is machine language. The computer does not understand any other language. It understands only machine language. But for humans, writing all programs in machine language is difficult. Therefore, high-level languages were created. We have discussed this in previous class. Machine language very difficult to understand. So, we have created high-level languages. But the program written in high-level language cannot be understood by the computer and therefore needs to be, just give me a moment, therefore needs to be converted to machine language. Thus, programs were created which translate the program written in high-level languages by the user into a machine language, which is called language processors or translators. Now, what happens in a high-level language? There is a high-level language, there is machine language. Okay, when you write something in high level language, it is sent to something called a language processor. It is in the middle. All right, this is the high level language, this is the low level language, and there is a language processor in between. So when you do it, when you write something in high level language, it is sent to a language processor or translator. Just give me understand by the very simple idea. Suppose you go to a place where people speak different kind of language. You may be speaking Hindi, Bengali, English, Nepali, depending upon what is your mother tongue, or some languages you may have acquired. But suppose you go to a foreign land and the people there do not understand any of the languages that you speak. So what happens? How do you communicate your ideas and expressions? You need a person who can translate, a person who understands both your languages and the local people's language. That person is known as a translator. Okay, similarly, even high level languages need what is known as language processors or translators. In order for you to give the command to the computer which understands only machine language, nothing else, alright, you have to give the command to a translator. The translator will translate into machine language, give it to the computer will solve that command, give it back to the translator will convert it back to what you understand in colors, numbers, languages, alphabets, alright, and give it back to you. So this is the job of a language processor or a translator. Just give me a moment, let me just, yes, alright. Okay, let us come to this. The programs were created to language processors. Thus, the language processors are programs that are responsible for converting an assembly language program or high-level language program to object code. Now, what is an object code? Let us read. Object code is a set of instructions or codes that is understood by a computer at the lowest hardware level. That is the smallest, the lowest level where the computer understands only that. Okay, so basically the high level languages convert something to the object code. Okay, and they convert it and give it to the machine. Alright. Thus the programs translated by language processor is understood by the hardware of the computer. Although the primary objective of language processors is for converting a program to machine language, but are language specific and can convert only one program written in specific language to machine language. Alright. For example, a translator of QBasic language can only convert program written in QBasic to machine language. Alright. Similar to a translator of C++ language can only convert program written in C++. Now, remember, translators are basically program centric. Alright. Sorry for that. That was my phone. So the language processors are basically program centric. If you have written something in QBasic, you need a QBasic translator. If you have written something in C++, you need a C++ translator. So you have to have different translators for different kind of objects. Sorry for that. Now, language processors can be broadly classified into three types. One is an assembler, the other one is a compiler, third one is a interpreter. Now, before we proceed to what are these three, let us read the small box that is written here. These two boxes that you see. Just give me a moment. Now, what is a language processor? If you pay attention, sorry for that. If you pay attention to the language processor, a language processor is a special type of software. Come to the left side of your screen, and you see there's a small box. Also, you can see it in your book. A language processor is a special type of software that converts source code to machine code. Simple idea. Alright. Now, what is a source code? Program written by a user is called the source code. And source code, when compiled, will result to object code. Now, basically, when you are writing something or coding in high level language, you are giving source code. It goes to the translator and translator converts it into object code. Source code, translator, object code, translator, source code. Alright, understood? So this is the system. Now we shall go to the next page. Three types of languages. Translators. Oh, that was very slow. Now, on the left hand side of the page, you will see there are three boxes given. You can read one by one. What is an assembler, what is a compiler, and what is an interpreter. Okay. Assemblers are programs that convert program written in assembly language only. Alright. Remember, we had talked about low level languages. There is the machine language and assembly language. Now, even assembly language is a low level language. Alright. Machine understands only machine language, that is 0 and 1. An assembly level language has got mnemonic codes. Now what happens is, when you give a command in mnemonic codes, it has to be converted into machine language, and for that you need an assembler. Alright, if you look at the small chart that is given here, very simply, easily, assembly level language, assembler, machine program. Alright, now what are compilers? You just read what a compiler is. A compiler is a program which translates a program written in high level language into machine language program that can be understood by the computer, or it may be an intermediate representation that is interpreted by the virtual machine. That is, example, Java bytecode. Okay. Generally, compiler reads the entire program and creates a separate machine code for execution. In case there are errors, it does not create a machine language code but lists all the errors for rectification. Now, for example, what is a compiler? Compiler is the one that directly converts high level language into machine codes. Okay, this is a compiler. Remember, compiler is a translator. Okay, it directly converts. If there is a mistake, it will show you on your screen that these are the mistakes that you have committed. Because if you are giving a code, if you say something which, when compiler is trying to compile it for the machine does not understand. The compiler will tell you, no, this is something the machine will not understand. Make it correct and then give it back to me. Alright, so the compiler will give it back to you and say, this is an error. ERROR, error. Now if you look at this diagram, simple diagram here, high level language, compiler, machine language. Now the last one is known as an interpreter. Now interpreter are also responsible for converting machine language, except this time it reads the program line by line and translates each line to machine language and executes it. Okay. In case there is an error, the entire process of translation and execution stops. Now, the difference between a compiler and interpreter, they are both the same. Okay, they are both the same. If you look at the two charts given, For compiler, it is high level language. This is my cursor. You see high level language program, compiler, machine level. Same thing is here at the bottom, high level language program, read line by line. Alright. If when you are giving a code to, when you are writing something in high level language and you give it to a compiler, what happens is the compiler will give it to the computer and take out a specific code. One code. If in the entire line, if there is only one mistake, it will show you that only that one mistake. But an interpreter does a little bit more difficult. What it does is, if you have made one mistake in a line of code, the entire line is sent back to you that this line has a mistake. Please correct it. Okay, it changes all codes line by line. Alright, now quite obvious, this was supposed to be there. What is the difference between compiler, sorry for that again, compiler and interpreter? Now let us go through. First, compiler takes entire program as input. Okay, interpreter takes a line as an input. Alright, compiler is taking the full program. Alright, I just make a small correction what I said. Compiler will take the full program. If there is one mistake, the entire program will go back to you, that you have made a mistake. Find out the mistake and solve it. Alright, but an interpreter will not send you the entire program. It will only send the line in which you have made the mistake. Okay, so you correct the mistake and send it back to the interpreter. Compiler, second point of differentiation is intermediate object code is generated. Interpreter, no intermediate object was generated, rather directly executes the machine code. Okay, now what a compiler does is, a compiler will take your input, convert it into what is known as an intermediate object code, okay, and then give it to the machine language. Okay, but an interpreter directly converts it into machine language and gives it straight to the machine. Alright, so the interpreter is a little bit faster than compiler. Conditional control systems are executed faster as compiler can optimize conditional control systems as the entire program is involved. Conditional control systems are executed slower as translation execution is line by line. Understand this. A compiler is a little quicker on the other front. Why? Because it takes the full program. If there is a mistake, good, it will send you back. Otherwise, it will send straight. One program, straight through. Alright? If in case of what happens in case of an interpreter, the interpreter will take one line at a time. Alright? The advantage is that your job is easy if there is a mistake. But the disadvantage is because it is going one line at a time, it will take more time. Alright? But when I say more time, in the world of computers, it is a fraction of a second. Remember, computers are very, very fast. Alright? So, it is a fraction of a second. Let's come to the next page. That is page number 9 on top. Okay, this guy doesn't want to move. So, I shall go out and I shall go in. Yeah. I should just zoom out a little bit. Arey tu hat ja bhai. He doesn't want to move. Alright, I can read it from here only. you people have your books, so kindly read your books. Next point of difference between a compiler and an interpreter on page number 9 on top. Memory requirement is more as an interpreter code is generated. Memory requirement is less, no intermediate code is generated. You do not need too much amount of space on your hard drive. Why? Because the compiler, what it does is, it takes your program, makes an intermediate code, and then gives it to the machine. So the intermittent code also will need some space. But in case of interpreter, there is no space required. It directly converts and gives it to machine language. So the space required is less. So the difference. Sorry for that again. So these are two differences. Next difference is program need to be compiled every time during execution. Every time the program is converted into lower level programs during execution. Now, what happens is, for a compiler, a program needs to be compiled every time for execution. Every time you do something, the program has to start. Okay, the full programs have to start. You have to create a new program for that. All right. Now, for interpreter, every time the program is converted into lower level, all it does is it just converts into the next level language. All right. If it is high level, it will come into lower level. Okay. Next, Errors are displayed after entire program is checked. Errors are displayed for every instruction intermitted if any. Now as I said, a compiler takes a full program, takes it from you, checks it and makes it into an intermeter code. Full program, okay? So once the full program is read, only then you can find out if there is an error. Suppose if you are giving a code that is 3 pages long, alright? What the compiler will do is it will check the full 3 page and then will give you the errors. But for an interpreter, it is easier. It will start checking first line, second line, third line. Fourth line, there's a mistake, it will send you the fourth line. There's a mistake, please check. Okay, while you are doing this, I'm carrying on checking. Okay, 4, 5, 6, 7. It will keep checking every line. And with every line there's a mistake, it will send you back the mistake. But it will keep on doing. So the correction, finding out of errors, whatever there are mistakes, is easier and quicker. It is slow for debugging, that is finding and removing errors. Easier to debug as only one error displayed at a time. Debugging I have discussed in the previous class. When there is a mistake in programming, when you have given a code where there is a mistake, the computer will not function properly or will function at all. Okay, so the particular mistake, sorry for that again, so the particular mistake is known as a bug. Okay, to remove the mistake is known as debugging. Okay, when you remove a particular mistake in a program, it's called debugging. All right. So in an interpreter, in a compiler, debugging is slow. Why? As I said, full program has to be checked. Pura check. The entire thing will be checked. Then you will send there's a mistake here. Then you send back the full program again. Again, it will check the full thing. All right. In an interpreter, it is rather easier. Why? Because very simple. It checks the one line at a time. So it keeps giving you the errors one by one. All right. So it is rather quicker. Okay. Now there is a small quick fact written here. Please let us have a look at it. A cross compiler converts a high level language program to machine level language for platform other than where it is running. For example, a cross compiler that runs on Windows 7 PC but generates codes that runs on Android. Smart. A cross compiler is a compiler which can, if it is working on my laptop, it can and if I ask it to work for my phone, it can fix my phone, okay, from my laptop, even though my laptop is using a Windows 7 while my phone is using an Android. Okay, so that will be all for today's class. What we will do today is we are going to go back at the activity that was shared for this particular class. Okay, I'm going to be sharing and you will see that the form is the same as it was before, but I would want you to redo the form. Why? Because there are a lot of people who did not do the form correctly last time. Also, some people who got it, some people, sorry for that again, some people who missed the form. So I would want everybody to have a look at the form once again and we shall continue with the next class. Okay, so until the next class, this is Alok sir saying bye bye.